So suppose we want to add the fractions 3/8 and 2/5. Well, what we have to do first in order to add them is to find the lowest common denominator. And that's the denominator which contains all of the unique factors in each of the denominators. So for example, if we want to add 3/8 and 2/5, our lowest common denominator first needs all the unique factors of 8, which are 2 and 4. We could express them as prime factors, but we don't need to in this example. And in our second denominator, the only factor we need is 5. So our lowest common denominator is going to be 2 times 4 times 5, which is 40. So now what I need to do is to multiply each of the fractions I'm adding by the factors in the lowest common denominator that it doesn't have. So for example, 8 does not have the factor 5, so I'm going to multiply 3/8 by 5 over 5, which is just another representation of 1, so it doesn't change the value of my fraction. And that will give me 15 over 40. My second fraction, 2/5, well, 5 does not have the factors 2 and 4, which are 8, so I'm going to multiply this fraction by 8 over 8, which will give me 16 over 40. And now I can go back and add these two because they've got a common denominator. 15 over 40 plus 16 over 40 is going to give me 31 over 40. And there's my solution. So now we want to add two monomial rational expressions, and we've got our denominators of 5b cubed and 3b squared. So let's take a look at all the unique factors in those denominators. Well, 5b cubed is 5 times b times b times b, and 3b squared is 3 times b times b, but we've already got b times b over here, so we don't need to add those anymore. So our lowest common denominator will be 15b cubed. Now I've got to multiply each expression by the factors in the lowest common denominator that it doesn't have. So I'm going to multiply 5b cubed by 3 over 3, and I'm going to multiply 2a over 3b squared by 5b times 5b, and now I'll get 3a over 15b cubed and 10ab over 15b cubed again, and now I can just add my numerators, so I'll have 3a plus 10ab over 15b cubed. And I'm not done. Of course, I need to list my restrictions, so I'm going to go back to my original problem, and I see that b cannot be equal to 0. Okay, and that will, so here's my solution. Okay, let me just get rid of that little mess there. Okay, let's take a look at some rational expressions that have polynomial denominators. So now I've got 6 over x minus 3, and I'm subtracting from that x minus 1 over x squared minus 5x plus 6. So first I have to find the lowest common denominator, which of course will be all of the unique factors in my denominators. Well, my first expression, the only factor is x minus 3. If I factor the second denominator, I will get x minus 3 over x minus 2 times x minus 2. Sorry. So the unique factors will be x minus 3 and x minus 2. And this will be my lowest common denominator. Now I have to multiply each expression by 1 in the form of the factors that it does not contain. So my first expression, 6 over x minus 3, needs to be multiplied by x minus 2 over x minus 2. My second expression does not need that because it's got both factors in its denominator. And now I'm going to distribute the 6 over both items in the parentheses there. So I'll have 6x minus 12 minus x minus 1 all over x minus 3 times x minus 2. So let's clean that up a little. Again, I'm going to have to distribute this minus sign over everything inside the parentheses. So I'll have 6x minus 12 plus 1, which will be 5x minus 11 all over x minus 3 times x minus 2. Do you need to express it as the original trinomial? You can. You can leave it in factored form. Neither is wrong. But what we do have to do is express our limitations, and we can see that x cannot equal 2 or 3 because both of those factors are in the denominator. And so here is our answer. 5x minus 11 over x minus 3 times x minus 2, with x not equal to 2 or 3. Let's take a look at one more example. We have x plus 2 over x squared minus x minus 6 over x minus 1. So let's look at all the factors that we're going to need in our lowest common denominator. X squared minus x can be factored into x times x minus 1. And we know that we've got just a factor of x minus 1 in that denominator. So we don't need to add any more factors to our lowest common denominator. So this expression is just fine the way it is. I'm going to leave that denominator in factored form. And I'm going to do 6 times x over x minus 1 times x. And so that will give me x plus 2 minus 6x over x squared minus x. And now I can just simplify this. I will have negative 5x plus 2 over x squared minus x. Going back to my original example, what can x not equal? X cannot equal 0. X cannot equal 1. Okay, the last example I'm going to leave you with is a little bit more complicated. I've got x plus 2 over x squared minus x, and then I've got 6, but this time it's over x squared minus 1. So let's factor these. I've got x times x minus 1 here, and in this denominator I've got x minus 1 times x plus 1. So it looks like our unique factors are x, x minus 1, and x plus 1. That will be our lowest common denominator. X times x minus 1 times x plus 1. And I'm not going to multiply it out yet because I'm hoping that I won't have to do that depending on how this problem goes. Okay? So what we're going to need to do is multiply each expression by 1 in the form of the factors that that denominator doesn't contain. So our first expression will be multiplied by x plus 1 over x plus 1, and our second expression is going to be multiplied by x over x, and I'm going to keep that denominator in factored form. So now when I start simplifying, let's just make a little room over here. Okay, a little bit of room. So I've got x plus 2 times x plus 1 minus 6x all over x times x minus 1, x plus 1. And let's clean this up. We'll get x squared plus 3x plus 2 over x times x minus 1, x plus 1. Let's not forget our 6x. And when we simplify that, we get x squared minus 3x, we're going to combine these like terms here, plus 2 over x times x minus 1, x plus 1. Are we done? I don't think so, because we can simplify this a little and get rid of some of these expressions. And I notice that my numerator can be factored into x minus 2 times x minus 1 over x times x minus 1, x plus 1. And I'm going to cancel out these two factors. X minus 1 over x minus 1 is equal to 1. And now I'm left with x minus 2 over x times x plus 1. And my last step, let's go take a look at what x cannot be equal to. We're going to go back to our original factors in our original expression, so we know that x cannot equal 0. Here we are factored down here, and it cannot equal -1 or +1. And that is our final answer. Sum up. When adding rational expressions with unlike denominators, you need to find the unique factors of all the denominators. To form a lowest common denominator. Put each expression over the lowest common denominator. Add or subtract. Simplify, if possible. And express any limitations. If you want some more examples of this, you can go look at the website purplemath.com. All one word. And she walks you through the lessons in written form, step by step. You can do it.